Hello, Mr. Samir. How are you?
Hello. Good
Hello.
evening.
Good
Can
evening.
you? Hello.
Hello, Dr. Samir.
Hello. Yes, we can hear you.
Can you guys hear me?
Yes.
Yes.
I can't hear your audio. Any one of you who can hear me?
Yes, we can hear you.
Yes, Mr. Samir, we can hear you.
Okay.
We hear you.
I was trying to connect. I mean, there was something wrong with the internet. So we're here. Welcome back. Today is our first session. So let me take you direct to the Moodle. Okay. So here we have the first session, and here is your lab exercise. Any one of you who doesn't know where are the lab exercise, you can go to your course section, and then from the first section of the course page, digital communication, you click on this one, and then we will have.
Hi, Dr. Samir.
Hello, Ahmad. Good evening.
Good evening.
So here we will be working with this lab today, AM double sideband suppressed carrier. All right. So let's open up this one. I hope all of you are ready with the MATLAB. Any one of you who doesn't have MATLAB? Is there anyone who doesn't have the MATLAB?
Hi, Dr.
We
Samir.
use the
Hello.
online MATLAB.
That's great. That's great. I mean, online or offline, it's one and the same thing. Doesn't matter. Whatever you like.
Yeah. And I go on the model. I found lab exercise,
Okay.
lab 1, right?
Yes, lab 1. This
Yeah.
one.
1 minute.
No problem. So this is our first lab. I'm going to open it up here. So this is digital communications, and here we have our first experiment, double sideband suppressed carrier transmission. Just 1 minute. I need to check. Okay, it's perfect. Okay, now we are here. Do you see my screen? Hello, do you see my screen?
Yes, Mr.
Yes,
Samir.
yes.
Okay, so our today's topic is modulation. Okay, amplitude modulation, but amplitude modulation has 3 types. First one is AM. This amplitude modulation, this is the short form of amplitude modulation, AM.
VM.
And this is not the time, this is amplitude modulation. AM, then we have AM double sideband suppressed carrier. This is one of the forms of AM. Then we have second form, which is AM double sideband transmitted carrier. And the third one, the third type of amplitude modulation is AM single side band transmission, which is also known as SSB. This one is in short form DS double sideband transmitted carrier, and this one is double sideband suppressed carrier. But the question is, what is AM? Any one of you who knows what is amplitude modulation? Do you have a little bit idea about what does it mean?
The amplitude for the signal, the A, the high. You mean the
No,
high?
no. The question is, why do we need amplitude modulation, and what is it actually?
Because I make the modulation
Why? Why?
for the transfer the signal.
Which
I
signal?
don't know in English.
You're right. You're right. You're getting
Yes.
to the point. But I mean, why are we doing modulation? Okay, you said we need it for signals, but
Yes.
why do we need it for signals? There should be a cause. There should be a
Yeah,
purpose.
because sometimes the signal is small. I must make modulation to.
No, no, no. That is amplification.
To make the signal clear and more big.
No, that's called amplification. Amplification means if you have a low magnitude signal or a uh, low value signal, you can increase it by an amplifier. But this is amplitude modulation. Look at this word. I'll tell you what it is. Uh, think about
Module the signal. I know to module the
think,
signal.
no, modulation is something. Think about this is a person, and he can he or she can shout loud. Now, the maximum distance that you can cover is, let's say, 500 meters. Or this person can, let's say he can sing a song, and that song can be heard a maximum of at a maximum distance of 500 meters. Now, what if I have to send that song, this voice message? What is this? Voice message, right? His
Yes.
his voice. I need to send it to, let's say, another country. To a longer distance, which is more than, let's say, 5,000 miles. Can I send it by wire?
No.
Why? Uh, uh, we can't use a wire for 500 miles, 5,000 miles.
No.
It's difficult, right? We
Yeah.
cannot carry a wire for longer distance.
I make modulation.
So the question here is, how do I send his voice signal to a very long distance? Let's say this person is in Kuwait, and we want to send his voice message to another country, let's say to Saudi Arabia, or maybe other part of the globe. Let's say, for example, let's say
To the London.
UK, London. Now, in reality, it's really difficult to carry a wire from Kuwait to UK. It's not possible, right?
Yes.
So the question is, how do we send this voice signal to UK? There's a way out. There is a logic. Usually, the low frequency signals. Remember this word. This is very important. Low frequency signals, LF. This person can speak or sing a song within a frequency range of, let's say, 20 hertz to 20 kilohertz. This is the audio. When we speak or when we listen to a song or when we listen to any form of audio, it's within this range. Beyond this range, we cannot hear anything. Okay. But beyond this range, let's say beyond 20 kilohertz, there is another band called radio frequencies band. So radio frequencies band exists above 20 kilohertz. So if I take a frequency of 30 kilohertz, it's a radio frequency. Okay. Now, why did I introduce radio frequency here? Radio frequencies can travel very large distance as compared to the audio. So if this person speaks and if he uses the full energy, a maximum distance he can cover is 500 meters, not even 500 meters, maybe 100 meters.
Yes.
Right? But but if we need to send this signal to a longer distance, then what we do is we take the signal and then we put it on this signal, because this is the radio frequency. It can travel a long distance with the same power. So it's like something like this. Before this, you had to walk, let's say from one place A to place B, and you went there by walk. Now, next time, what you're doing is you are taking a car. Sorry, I'm not a good artist.
It's okay, Mr. Samir. This one airplane, Mr. Samir, not car. Mr. Samir, can you hear me? Because the connection for you.
Usually we use a car to carry a person from. Can you guys hear me? Am I audible? Can you hear me?
Yes, now. Yes.
Okay. So I was talking about, let's say this person A, if he walks, it will take him a long time to reach to the other distance B.
Yes.
Similarly, if the same person A uses a car, now this time we are using a carrier. Car is basically a carrier, right?
Yes.
It can carry a passenger from one place to the other.
Yes.
Same thing happens with the message. Now look at this one. Look at this scenario. You have got a car, and this car can travel at a very fast speed compared to the speed of a human being. So we are basically using two things here. One is the passenger and the car. The passenger is sits in the car, and then basically car moves, not the passenger. Right?
Yes.
Here we do the same thing with the modulation process. What we do here is we have got a voice signal. Think about it's a person, and we need to send him to the other location. And to send him to the other location, we use a carrier. And carrier is nothing but a radio frequency. Okay?
Yes.
So just to write it again, we take voice message, we take a message signal, and then we edit it with carrier. Once it passes through the air, because we are transmitting through air, we are talking about wireless communications. So we mix message signal and carrier. So what travels here is carrier, because carrier can travel at very fast speed. Carrier is nothing but a high frequency. This one is your low frequency. This one is your high frequency. But now I have a question for you, to all of you. Can you tell me how should we define low frequency and high frequency?
speed? About speed?
Of course, the speed here is high because this is radio wave. Radio wave has the speed of light, 3 times 10 to the power 8 meter per second. This is the speed of radio wave, same as that of light. And this one is low frequency. Its speed is low. Now, my question is, how should we define high frequency? What is high frequency and what is low frequency? Let's say you have got 2 signals like this.
A little time, small time. Or
Remember, usually low frequency, when we say the audio frequency, for example, starts from 220 hertz to 20 kilohertz. This is the low frequency range or the audio frequency range. The music that you hear or the words that you speak or the conversation that you hear from your ears is basically within this range. Beyond this range, you cannot hear. Okay, this is the audio range. Now, if you talk about radio frequency range, it starts with 30 kilohertz to, we have now different bands. It goes up to 300 gigahertz. It's a very huge range. That's why it has been divided into different bands. I'll show you something, just a minute. Can you see my screen?
Yes.
No, Mr.
Now? Can you see it
yes,
now?
Yes.
Okay, have a look. This one is a very old radio receiver. You may have seen it before in your car. Nowadays we have digital, but this one was used before, a long time ago. Have you seen it? This one, radio.
yes,
This radio has a scale. You may have seen the scale like this. And in this one, you will find different frequencies written on the scale. Like, let's say, for example, let's take this one. You see here it's written 88 megahertz, 92, 96, 100, 104, 108. This is the megahertz range. Similarly, we have kilohertz range. This is medium wave, short wave, FM, right? All these are frequencies. And these are basically the radio frequencies that you receive on the radio. And what you hear from the radio is audio. You understand my point? So here in this example, we are mixing an audio with the radio wave. Why? Because our goal is to transmit, to send this audio message to a very long distance so that it can reach to the other end of the globe. Is that clear?
Yes, clear, Mr. Sam.
Do you have any questions until now?
No, clear.
So can I ask one question? Why are we mixing these two? What is the objective? Why are we mixing our voice with a radio signal? What is the objective?
To find the lower and higher frequency.
No. We are not finding the lower and higher frequency. Our goal is to send our voice to the other end. You know,
Right.
when you use WhatsApp, you
Yes.
send a message signal. Let's say now this is not your voice message. This is your text message. Hello. You cannot send this hello to the other end without a radio wave. So what we do is we mix this with the radio wave, and then we send out this through the antenna. And at the other end, the antenna receives it and shows you the message. Okay. Now the question is, what is modulation? Modulation means the superimposition, or I would say in simple terms, mixing of the message signal with the carrier. That's modulation. So we mix them. There is a device called mixer, which takes two signals, the message signal and the carrier, and it gives you a radio wave, which you can send out in the air. Do you understand? So let me make it simple now. This is a mixer, and we have message signal M of t, and here we have carrier signal MC of t. So can you tell me now what is M of t? Is it a high frequency signal or a low frequency signal?
Low.
Low frequency. And what is MC of t?
Carrier.
This is the carrier. What is the difference between these two signals?
Frequency.
A message.
Yes, the frequency is the difference. This is a low frequency signal and this is a high frequency signal. That's the only difference. When you mix them, there is a device called the mixer. Usually it uses transistors and resistors and capacitors to mix these two signals. And then this device gives you an output, which is a multiplication. Let's say this one, M of t times MC of t, means carrier multiplied by the message signal. And when you multiply them, you get result. How do we define M of t? Do you know that? How do we represent a sine wave?
Multiply with cosine?
No, with cosine. We say A sine cosine omega t, right?
Yes.
Plus theta. Theta, I will write here,
Yes.
th. This is a general representation of a sine wave. So here it will be exactly same again. This is a message signal, so I can write it MC of t equals to AC, means the carrier, amplitude cosine omega t plus theta. Theta, let's assume that theta is 0. So omega t, right? And here M of t will be M of t equals to A. Now AM means here, this is actually subscript, the message. Like here, okay, I can write it like this. AM means the amplitude of the message signal. When I say AC, this is the amplitude of the carrier. This one. Okay. Again, cos, cosine, omega t. Do you understand this, what I've done here? Any questions?
No, clear.
So what did I do here? I took two signals which are represented by AM cosine omega t and AC cosine omega t. AC here is the carrier. Sorry, MC of t is the carrier and M of t is the message signal. When we mix them, we get a different signal, which is a combination of these two. Let me show you now mathematically what we're doing here. Look at this. We are studying double sideband suppressed carrier. Amplitude modulation is a simple modulation approach and serves as a base of digital modulation schemes. It is a process of mixing of two signals. Do you understand this? It is a process of mixing of two signals. One, which is a high frequency radio carrier wave, with the other, which is a low frequency or information signal. Is it clear? Do you understand this definition now?
Yes.
Perfect. Now, there is a technical term. Usually, to understand this concept, I used the word mixing. In communications, we don't say we mix signals, we say heterodyning process. I don't know exactly. Heterodyne process. Heterodyne process means the mixing of information signal with the carrier wave. Sometimes we call it information signal, or we also call it a message signal. It's one and the same thing. Okay. Like for example, if you want to send a text message, it's a message signal. Or you may send a data, like a file or an email. That's an information signal, right? But all of them will be sent to the other location by using a carrier wave. Now look at this. Now what happens here? Here is the very important point. When we mix these two in a mixer, it results in three forms. Either we can have amplitude modulated signal with double sidebands plus carrier, or we can get amplitude modulated signal with double sidebands, no carrier, or we can get just a single sideband. Now you may ask, what is this sideband? What is this double sideband, right? Think about we have a mixer. Let's say we are using a low frequency signal of 2 kilohertz, okay? And the carrier should be higher than this, right? Let's say the carrier frequency is 15 kilohertz. Which one is the carrier and which one is the information signal here?
The carrier 15.
Right. So this is
The
your
message is 2.
so this is your MC of T, the
MC,
carrier wave.
yes.
Right. Which is the information signal, this one, or the message signal. So we write M of T, the message signal.
Allah.
Okay. Here is the difference. In double sideband modulation, DSB, what you will get at the output of this mixer is you will get carrier, you will get this one 2 kilohertz, plus 15, I'm sorry, I just wrote it opposite. I will write it here because with mouse it takes a long time. 15K plus 2K, and you will get 15K minus 2K. How much is it? Do you understand this? If it's double sideband transmitter, you will have two sidebands. Sidebands means carrier plus and carrier minus. So it's basically a mixture of frequencies. You will have addition of carrier and message, subtraction of carrier and a message. So when you try to put this in the frequency domain representation, what you see is here, you see one sideband here and one sideband here. Means if this is your carrier 15, Plus 2 means 17. Minus 2 means do you understand this?
Yes.
This is the amplitude. Okay, what is this one? What is this one here? Do you know we measure signals? How do we measure signals? We use an oscilloscope, right? And oscilloscope will show you a signals in time domain. Sometimes you may have seen oscilloscope showing you signals like this. Here, this is the time and this is the amplitude, right? But when we are measuring, when we want to analyze frequencies, we use frequency domain representation, where you have frequencies on the x-axis and on the y-axis you have amplitude. Is it? Do you understand this one? This is time domain signal. This one is sorry, frequency domain representation of frequency domain representation. Here you represent, here you show different frequencies available in a signal. So what is DSB now? Yes.
Double sideband.
DSB, double sideband. So we have two sidebands. These
Yes.
are called sidebands. This
Yes.
one is called lower sideband. This is LSB, lower sideband. This one is upper sideband, USB. And this one is your carrier. But in double sideband, the carrier is suppressed. Suppressed means the carrier is not transmitted. So this signal does not appear. So what do I mean by this? Look, when you travel in a car, first you get in a car and then you drive a car, and at the end, when you reach to a destination, you don't carry car with you, right? You don't take car with you, you just leave the car. You park it somewhere and that's it. So in that case, the car is acting like a carrier. And then you leave the carrier. But in this case, what we're doing here is, since we are generating two higher other frequencies by mixing these two, so we don't need carrier at all. This one also contains the message. This one also contains the message. This is one way of modulation. Since we are changing the amplitude of the carrier, one thing I forgot to tell you is what is amplitude modulation. Okay, until now I told you, I explained about what is modulation or what is mixing. Modulation means when we mix the carrier and the message signal. That's modulation, right? We have an information signal like this. We send it to a mixer, and to the mixer we also send another signal which is called carrier. This information signal and this carrier signal, when they are mixed in the modulator. So what do we use for mixing? We use modulator for mixing. So modulator is the device which mixes these two signals. But here you have to be very careful. We have two types of modulation schemes. One is the amplitude modulation and the other frequency modulation. Since we are studying amplitude modulation, so we will just focus on amplitude. What happens in amplitude modulation is if this amplitude, if the carrier amplitude, let's say for example 2 volts, plus minus 2 volts, this amplitude changes according to the amplitude of information signal. When you mix these two signals, what will happen to the carrier is the carrier amplitude will either go up or it will decrease.
Victor,
Yes.
I didn't find the link for the MATLAB in Moodle. For the MATLAB.
MATLAB, there is no link for MATLAB. You have to go to the matlab.com.
The right MATLAB website?
Yeah, MATLAB website. There you must have an account.
Yeah, I have. Okay.
Yeah, once you open up that, they will find on the left panel there is an option called MATLAB Online. When you click on that, it will open up the online version.
Okay.
So you're welcome. I want all of you to understand this. Do you understand what do you see in this picture here?
Yes,
what is this
Mr.
one?
Samir.
What
Yeah.
is this one?
The amplitude and in the
This is
middle, the carrier.
Yeah, this is your information signal.
Yeah.
And this one is the carrier signal. Information signal and carrier signal. Look, this information signal has a constant amplitude. This carrier has a constant amplitude. But when you mix them in the modulator, but which modulator? The amplitude modulator. Here we are talking about the amplitude, means this carrier amplitude will be changed according to the amplitude of the information signal. So if this goes high, then carrier will also go high. Now it will not be just 2. You know, if in this modulator, if I for example remove this one for a while, what will be the output of the modulator? Will there be any changes in the amplitude? No. But when I use information signal, what happens? This carrier amplitude gets changed. It doesn't stay now 2 or minus 2. It sometimes goes 3 because it adds up with the carrier information signal. And when the carrier in amplitude is changed by applying information signal, then this amplitude, this modulation scheme is called amplitude modulation. Do you understand? Do you understand now what is amplitude modulation? Guys,
Yes.
any one of you have any questions?
No, clear, Mr. Samir.
So can you explain what is amplitude modulation now? Because look, if you understand today's concept, then all the labs will be easier for you. Please pay attention today, because this is the beginning. If you
Mr. Samir, all the lab is amplitude modulation. I focus this.
No, all the labs will have same concept, but
Same concept.
sometimes we may use amplitude modulation double sideband, amplitude modulation single sideband, or we may use frequency modulation. But the modulator and the mixing is almost the same. Okay, the concept is same, the background is same. So here, yeah, you were talking about the amplitude. Can you please explain what do I mean by this? Can you just explain a little bit what you understood?
The mix
Anyone?
with the message and carrier, the amplitude and carrier.
Okay.
Yeah.
So what happens to the carrier when I mix it with the information signal? Does its amplitude remain same or it changes?
Change.
let's say I don't use an information signal. What will happen to the carrier? What will be the output here?
The amplitude, and in the middle the carrier.
I'm not using information signal. I'm just using the carrier. So is there any mixture? Is there any mixing?
No.
No. So what will be the output?
The carrier.
Exactly. Output will be carrier because there is no information signal. In that case, the amplitude of the carrier will remain same. It will not change. But if you mix it with the information signal, let's say your voice, what will happen to the carrier?
The amplitude and carrier here.
Exactly. The amplitude will change. I will show you one thing more here. Let's say your signal is like this. This is your message signal. And here what you get at the output is you get something like this. This is your carrier whose amplitude is changed.
Yes.
This carrier was having a constant amplitude, but when we applied the information signal, its amplitude changed. And when its amplitude changed based on the amplitude of the information signal, we call this process amplitude modulation. In simple terms, to make it easier for you to understand, amplitude modulation is simply changing the amplitude of the carrier by the amplitude of the message signal. Is that clear?
Again, Mr. Samir, change the amplitude for the message?
No, changing the amplitude of the carrier, changing this amplitude, carrier amplitude, by the message amplitude.
Yes, yes.
So here, who is controlling the amplitude of the carrier now?
Message.
Exactly. Message is controlling the amplitude of the carrier. That's why this process is called amplitude modulation. Is that clear now? What's amplitude modulation?
Yes, clear.
Yes.
So until now we have understood what is amplitude modulation. Now let's go a little bit back where we stopped. We talked about the double sideband and plus carrier, double sideband with no carrier, and single sideband. As I told you, amplitude modulation means changing the carrier amplitude with the information signal. But when we do that, actually three things happen. Three things happen here. Either we get two sidebands, means an addition and subtraction of the carrier at the output, plus the carrier itself. Or some modulators, they just mix the carrier with the amplitude to generate just double sidebands without any carrier. In other modulator types, we only get the single sideband and we remove the carrier and other sideband. Now, what's that? Let's say you have a message signal of 2 kilohertz and you have a carrier of 50 kilohertz. When you mix these two frequencies, what happens? If it's a double sideband modulator with suppressed carrier, it will add these two. So what you will get here at the output, 25? When you add them, no, you will get 50 plus 2 is 52.
50 plus?
50 plus 2.
52, yes.
Right? And yes, also you will get 50 minus 2, which is?
48.
48. So you will generate
48,
two frequencies. But it will all depend on this modulator type, which one you are using. If you're using double sideband without carrier, so there will be no carrier. Means 50 kilohertz is missing. There will be upper sideband, there will be lower sideband, but no carrier at the output. And in this case, it is this modulator, double sideband. But we also have another type
Sir,
of
no hub carrier. How I calculate the
calculate what?
when no hub carrier? How I calculate?
I didn't get your question exactly.
I not have carrier the 50. How can I calculate the
Just
amplitude modulation? Yeah.
I will tell you, no problem. Look, this is your 2K, okay?
Yes.
And this is your, let's say, 50 kilohertz signal carrier. If you are using a double sideband suppressed carrier modulator here, means a mixer which generates a signal without carrier, which removes the carrier from the output. So what you will get here, you will get the message signal, which is the carrier plus message and carrier minus message.
Minus message. Yeah, this one for the this one I know.
This is for which one? This is for double sideband suppressed carrier.
Yes.
Suppressed carrier means there is no carrier. You will get only two sidebands. One is 48K and the other 52K.
Oh, there is without carrier. Yeah.
There is no 50 kilohertz.
Yes. Okay.
But if you are using, let's say I will choose the different color for this. Let's say you are using now this modulator, double sideband transmitted carrier. In that case, the output will not be this. Output will be 50K plus 2K, 50K itself, 50K minus 2K. So how many frequencies are there at the output? Sorry, I will make it plus here and minus there. This is 52K. And here we have 48, right?
Minus, Mr. Samir.
Yes.
Sorry, yeah, minus, sorry. So we get here 50K.
3.
Carrier, yes. 50 is carrier.
We get carrier here.
Yes.
50 is carrier. So in this case, we are transmitting 3 signals. We use antenna. That antenna sends out in the air 3 signals. One is the lower sideband, upper sideband, and the carrier. But if we are using this one, then we only use 2 sidebands for transmission. In this one, we can transmit 2 signals at the same time. Now the problem is here. Look at this one. Every device needs power for operation. If we are transmitting 2 signals, these 2 signals will take some energy, right? And if we are transmitting 3 signals, means they are taking more energy than the 2 signals. They will consume more power. Have you observed that when you try to use video, when you try to make a video call using mobile phone, your mobile phone starts heating up? Have you observed that? When you make a video call, the mobile phone heats up. But if you make an audio call, it doesn't affect. Means when you are sending more data, the battery is drained. The mobile consumes more battery. But when you don't make a call, or when you don't use a mobile phone, the battery the battery remains.
Yes, that's right. Will be less.
Battery is less consumed. Similarly here, if we are transmitting 3 signals, these will consume more power. But if we are sending out 2 signals, these will consume less power. So which one is the good approach? Which one is the best modulator here?
Double sidebands.
Double sideband.
is carrier.
Suppressed
Without
carrier.
carrier, yes.
Yeah, without carrier. There is also the third one, which is called single sideband.
The best
SSB.
one, the single, right?
Yes, yes, SSB. In single sideband, we either take this one or this one. We take only one sideband and transmit. We skip the other one. Let's say I'm writing here. Let's say this is your single sideband. We will either transmit 48K, 50K plus 2 means 42. If we are transmitting only one sideband, then it's called single sideband transmission. Basically, it's an extension of double sideband. In double sideband, you have two sidebands, right? But you send out both the signals from the antenna. But in single sideband, we only pass one signal and we stop the other signal. So in that case, we are saving energy that our transmitter consumes. We are saving power. So either you can send out this signal to the output to the antenna, or you can send out this one. That's 48K, sorry, K equals to 48. So you can choose any one of these and send them out. So now, do you have the idea what we're doing here? And one thing more, let me write it with the other color, let's say black. Here, this one is called lower sideband, and this one is your upper sideband. When we are using double sideband transmit, we transmit both the sidebands at the same time. But if you are using single sideband, then either you transmit a signal on lower sideband, or you can use upper sideband, but you don't use both of them. Why? Because if you send both of them, these both frequencies will consume a lot more power. But if you use only one for sending out the signal, then it will consume half of the power. Means if your battery was if this consumed battery for 10 hours, now this one will give you 20 hours, because it's taking less battery, it's consuming less power from the battery. Do you understand the concept now?
Yes.
Clear.
First of all, okay, let's wind up the whole objective of whole session. First of all, tell me, why do we need amplitude modulation? What is the purpose? Quickly, please. Any one of you. Why do we need amplitude modulation? Hello, can you hear me? Hello?
To, yes, to add a message with the carrier.
Okay, but why? Why do we add them?
To send
Yes, to send it to the far away place.
far, yes.
To a longer distance, yes. And what is amplitude modulation?
Change would be in amplitude.
Change amplitude of what?
Of frequency.
By what? Okay, you change
Area.
frequency. We change carrier amplitude by
Message.
right. That's amplitude modulation. And how many types of amplitude modulation types we have?
3.
We have 3 types of modulation schemes, yes. And what is the difference between these 3 types?
without carrier, with carrier and one side.
Yes, but why do we do that? Why are we using three types? Why don't we use only one type? Because our objective is to save energy, to save power. That's why we have three different types. Okay, before you used to have Apple phone 6. Now next came Apple phone 7, and then 8, then 11. What is the difference? All of them are phones, right?
Yes, but power, energy,
Exactly.
and yes,
Exactly. They are more efficient, they are more reliable, and they are more fast, right?
right.
Similarly here, SSB is better than the double sideband transmission. And double sideband suppressed carrier transmission is better than transmitted carrier modulation. Okay, just a last question and then I will stop here. What is modulator? What is a modulator?
A
Okay,
process.
but what is basically that? I mean, what is this? What does it look like? Have you seen it before?
A wire, or it is a channel to send a message.
No, no. Channel is the air. Channel is the medium by which you send out the message. Look, if I connect an antenna here, like this, then on the other side, if I have to receive the same signal, I need another antenna. Have you seen this one? Have you seen it before?
Yes,
This is called a transceiver. Transceiver uses antenna. This antenna sends out waves in the air, and air is the channel. Channel means I don't know what's called tariq in Arabic, I guess. The road, like a road through which the message
yes,
goes on. Here, there is no wire, there is no link between the two, but there is air in between these two antennas, right? When you use this device, what is around it? What's around this antenna?
air.
Just the air. So it sends out the signals through the air. So air is the medium now. I don't know what you call medium in Arabic. I would say it's like a path. Okay, it's a path for the message to flow, for the radio signal to travel. So here radio signal is traveling through air to reach to the other device.
Yes,
And this air is the channel here. Sometimes we may have an intercom like this. Like this, wired intercom. Have you seen this one? Wired intercom where people can talk to each other by using, but this one here uses a wire. It is not wireless. Okay, so this one is also used for communication, but it uses wires, whereas this one, what you see here, is wireless. And what we are learning right now is about wireless, how we can send out radio waves in the air with our message signal so that they go to the other country or they can go to the faraway places. Usually you hear a radio station in your car, right? There's a FM station. Have you heard the FM station? What is the frequency for that? Kuwait radio station, radio FM.
88.8 and
Something
90.4.
yeah.
Yeah, it depends on the channel.
Right. It depends on, no, it doesn't depend on the channel. It depends on the radio frequency they use. So they can use 90 megahertz, they can use 88 megahertz. So they can use different radio frequencies. And when they use different radio frequencies, we also call them channels. But there the channel means the radio frequency. But when we talk about the medium, medium is also a channel. Medium means the path. Okay. I hope now the concept is clear, what we are talking about and what this topic is all about. Is it? Is it
Clear.
clear now?
Yes.
Great. So let's go to the maths. This is about double sideband suppressed carrier, means we are not using carrier in this lab. And in this lab, what it says mathematically is we have got a double sideband signal here, which is a mixture of information signal and carrier signal, right? Mi of t is the information signal and MC of t is the carrier signal. So we mix up these two signals to get the double sideband suppressed carrier. Now, to show you mathematically how does it work, we have a message signal which is A cosine omega t. Is it? Do you understand this?
Yes.
This is your message signal Mi of t, which
Yes.
is AI cosine 2 omega t. And we have also carrier. Carrier is carrier cosine AC cosine omega t. So we have message signal, we have carrier signal. And what do we do? What is this one here? Modulation, because we're mixing them, multiplying them. And here is the multiplication. This is your information signal and this is your carrier wave. Here we are mixing them, right? So A cosine omega t times A cosine omega t. What do you get? Cosine omega minus, this is this identity, you know that? What do you call that? What is this one? Cosine A times cosine B. What is that? Cosine of A plus B, right? Plus cosine of A minus B. Is it? Is it correct? But there is divided by 2. Are you with me?
Yes, Mr. Sam.
Yes, doctor.
Right. So do you agree with this? Cosine A times cosine B is cosine of A plus B plus cosine of A minus B. Here you have the same thing. A times A is AI times AA, right? These are two in multiply. AI times AC, which is here. And this 2 comes from the formula cosine omega t plus cosine A times cosine B. Cosine of A minus B, cosine of A plus B. Is it right? Over 2. And this is your signal. Look, we have got two frequencies, omega plus, omega C is the carrier and omega I is the information signal. So two frequencies are subtracted, two frequencies are added. Do we have carrier here only? We don't have. We have carrier plus information signal, carrier minus information signal. Do you remember this? Which I showed you before here. Carrier plus information signal, carrier minus information signal, right?
Yes.
This is the same thing. But the amplitude goes AI over AI times AC over 2. This is the mathematical representation of double sideband modulator. Now we are going to implement this in MATLAB. In MATLAB, what we'll do here is, if you look at this, what is this one? Can you tell me now what is this one?
Mixer, doctor.
Mixer, or we call it, in technical terms, we call it modulator, which
Okay.
is basically a mixer. So we have got a mixer, and what are we mixing here? What is this? Information signal.
The MT and MC carrier.
Exactly. MT and MC. We're mixing information with. So what do we get at the output? double sideband signal, right? And as I told you before, this carrier wave is nothing but it's a signal, but it has a very high frequency. Again, information signal, it's also a signal, but having low frequency. Do you remember that point? Those 2 points which I told you in the beginning. I asked you one question: what is the difference between carrier wave signal and information signal?
The carrier is the high,
Yes, high frequency
right?
signal.
And
Yes,
the other one low.
exactly. This is the difference. And when we mix them, we get a double sideband signal. Now the question is, how do we see those signals? How do they look like? Okay, I showed you, I told you that we mix them together, right? But now, how do I see them? Think about, you need to measure voltage. Which instrument do you use for measuring voltage? How do you measure voltage? If you go to the lab and I asked you to measure voltage on a resistor, how will you do it? If I will give you a task to measure the voltage, which instrument will you use?
Oscilloscope.
You can use oscilloscope, or you can also use multimeter, right? Or a voltmeter.
Yes.
Similarly, if you are mixing two frequencies, now how do you measure the output? We need some device, right? We need some instrument that will help us to see what is at the output. And for that, we use this one, scope. Sorry, we use scope for looking at the signals in time domain, and we use spectrum analyzer. What do we call it? What do we call it? Spectrum analyzer. This is an instrument which will show you how many frequencies are there in a signal which is available. So what's the job of spectrum analyzer? Yes. Hello, can you hear me?
To measure output.
Not to measure output, but to measure what is in the output. If there is an output signal, what is inside it? How many frequencies are there in the signal? You had 2 kilohertz signal here, you had 50 kilohertz signal here, and this one will be your third signal like this. But it looks like just one signal, right? But it is not actually one signal. It's a mixture of these two. In time domain, you cannot find out how many frequencies are there, but when you use a spectrum analyzer, it will show you something like this. In spectrum, and you can see this is frequency 1, let's say 2 kilohertz. This is 3 kilohertz, something like this. You will also see carrier 50 kilohertz here. You will also see 48 kilohertz here. Do you understand? This is what we will see on the spectrum analyzer. Spectrum analyzer is a device that shows you how many, what frequency components are available in a signal. Although this signal looks like just one signal, right? But it's not actually one, it's a mixture. Now let me show you something. Okay, let's go to the code. Let me close it first. This one and this one. Okay, as I told you before in the last lab, I told you you need to have this folder ready. You go to AM and then go to simulation. And then in simulation, you'll find the first experiment, which is titled by this AM DSB suppressed carrier, right? When you double click on it, it will open up a Simulink file. Do you see this one? Here, what is this?
Mr. Samir, what I press first?
Okay. You go to this folder,
Yes.
MATLAB EE352. Double click on it.
Yeah.
And then go to AM.
This one I already make it with you before. Where I found now?
Can you share your screen, please?
Yeah, one.
Guys, if any one of you have any questions, please you can ask.
Doctor,
Yes.
how can I delete or remove my old materials or my past subjects in the MATLAB file?
Would you please share your screen? I will help you.
Okay, please. Doctor, I use my laptop, so I will open my camera, huh?
No, you don't need to open camera, but you just share your screen.
Because I call you on the phone by this one.
Okay, no problem, that's fine.
Okay.
Who was calling me before? Allah, okay, Allah. Right. Okay, maximize this window. On the left, okay, hold on. Can you give me the remote control? Okay, look at this one here. Here, you have got this folder. Let me move it up first. Okay, we don't have it here. Look, you have got this folder, EE352 MATLAB. This is a zip file. You need to first extract it. So right click on it. Right click. No. Right click on this one. Click extract. Up. First one, extract. Okay, here you have the folder now. You see this? Again, right click on it. And then click add to path. Wait. Right click on this folder and then click add to path, this one, and then select this option. Click on it. Now it's ready. Double click on this folder. Double click on it. Again, double click. Click again. Click again. Here is your file, AM double sideband suppress care. Double click on it and it will open up. Okay. Who wants to share screen? Please go ahead.
Thank you, Mr. Samir.
I will.
No problem. Yeah, go ahead.
That's my laptop.
Well, I can see it from here.
Is that?
I'm sorry, I won't be able to help because no. This you don't need this code. Actually, I need
Doctor, because this is a past material or a subject, you know. So I want to delete. I want to delete all my files, the past file, the last course.
Right. What I'll tell you is, see, I have recorded a previous video which is available on Moodle. You go to that, you see that I have already explained the steps, how you can download the material from Moodle and how you need to upload it in your Moodle account. All the steps are given. If you don't, if you find it difficult, I will explain it again. Right?
Okay, I will check.
But if you can share your screen, I will show you now because from here I cannot see it clearly.
Okay. So I will attend the Zoom and the laptop.
Yeah, that will be fine. Yeah, that will be fine. I can help you with that.
Doctor, can you help me, please?
Sure, please share your screen.
Okay.
Ahmad Al-Muteri, everything is okay?
I don't know how to put the file you said the last lab.
Did you download that from Moodle?
Yes, there is two, doctor. There is MATLAB student new zip. This one, right?
No, not the new zip. The old one.
The MATLAB student zip.
Yeah, that one.
Okay.
Can you drag that here?
Where, doctor?
Yeah, in the same place. Yes, you need to
Here?
drag that file here. Yes.
Okay.
Just drag and drop. That's it. Ensure that the
See,
file
doctor, yeah.
selection does not contain files. Okay. Can you click on import data? No, up. In the menu bar, you should see import data.
Here?
Yeah, this one. Oh, yeah, this one. Click. Now, where is that file?
I don't know, doctor.
Okay. Can you just give me your control? Okay, hold on a minute. Actually, you are using. You are actually sharing only the MATLAB. I need the screen view, the desktop
Okay.
view.
I will share again, okay?
Okay, no problem. Okay, just hold on for a while. I'll first finish this experiment, then I will take your queries one by one, okay?
Okay.
Okay, just give me a few minutes. I'll come back to you again. Because otherwise we will lose the concept, what we learned before. Okay, guys, have a look. When you open up this file, this one, AM double sideband suppressed carrier, you should be able to see this block diagram, spectrum analyzer window, and the time scope window. Okay. If you look at it, here is the time spectrum analyzer. Now I want to ask you something. Do I really need this thing here, matrix concatenate? What is my objective? What do I want to measure? What do I want to see? My objective is to see what is in this output signal, right? So I don't need this much. I can remove it, right click and press delete. Delete this one, delete this one, delete this one, and this one. This is what I need. Do you understand this?
Mr. Samir, where I found this one?
Which one?
This one circuit, because the internet.
It's here, and this
Where?
one. Simulation AMDSB suppressed carrier, first one.
Mr. Samir, from where I get these files?
It's available in Moodle here. You see this MATLAB student.zip. You can download this and add it to the MATLAB account. Just drag and drop. That's it.
Okay.
Okay, once you do that, you will find this one. Now watch. I'm using spectrum analyzer. Look. How do I know what is the information signal frequency? And how do I know how much is the carrier? Do you know what is the carrier frequency here? Yes?
No.
So how do I know? Double click on this box and you will have something here, variable name AI. This is amplitude.
Again.
Double click on this in this DSP box, DSP block. When you double click, you will have a window like this, where it says single tone AI.
Doctor,
this
I
is
attend in the laptop, huh?
Okay, great. I'll help you with. This is amplitude of the signal, this is frequency of the signal, and this is phase. You know, A sine cosine omega t. This is amplitude, omega, and phi. And you can find these parameters here. Do you see this? What is this here? Single tone, right? Double click. What do you see? Amplitude of the information signal, frequency of the information signal, and phase of the information signal, right? Is it correct? Yes or no?
Yes.
Perfect. Now, what is this one? Carrier. Double click on it. So this is your information signal, side tone. Side tone means your information signal, and carrier is your carrier frequency. Look at the carrier frequency. How much is the carrier frequency here? 15 kilohertz. Means 15,000 hertz. And how much is the signal frequency? Information signal frequency? 2 kilohertz. So we are mixing in this block diagram, we are mixing 2 kilohertz with 15 kilohertz. Right?
Yes.
Let's see how does it look like. If you run this, so here is your 2 kilohertz signal frequency, information signal frequency, and here is your 15 kilohertz carrier wave. And when you mix these two together, what should be the output? What do you expect?
How much, Mr. Samir?
This is 2 kilohertz.
2
this
and
is 15.
52.
And just only
And
one side then?
48.
48. Remember, this type of modulation where you're multiplying carrier and information, this is double sideband modulator. So in the output, you should be only able to see two signals, lower sideband and upper sideband. Let's see. Now look, if I run this, let's click simulate. Let's see, what do we see? Did I click run or no? Now it's simulating. Please wait, it says initializing, you see? Initializing. Here there will be no output because I removed all these. What do you see here? In the spectrum analyzer, what do you see? Yes. This is our spectrum analyzer, and in spectrum analyzer you can see that the output here has two peaks. What is the frequency? Yes. Hello, can you hear me?
Yeah, 13 and 17.
Exactly, 13 and 17. These are the two frequencies. This one is your lower sideband, this one is your upper sideband. So when you mixed 2 kilohertz with 15 kilohertz using a mixer which is a double sideband suppressed carrier type mixer, what you get at the output is only two sidebands and the carrier is removed. There's no carrier 15 kilohertz. Is it clear? Do you understand this?
Yes, yes.
Yes, doctor.
Any questions?
Doctor, my
Yes.
question is how to remove or delete or erase the file
How to,
for the MATLAB.
okay, I will show you. I will show you. Just a minute.
Okay.
Just a minute. I'm about to complete this. If you remember, we also have. I spoke about free spectrum analyzer. So what do you see on the spectrum analyzer? Basically, you see how many frequencies are there, right? In the output, and what is the amplitude of each frequency. This is called spectrum analysis. Means we're trying to identify how many frequencies are there in a signal. Basically here, this block generates one signal. But that is not just one signal. It has two frequencies inside it. You understand? Do you understand this point here? What I just mentioned?
Again, Mr. Samir, please.
This signal, which is coming out, which is a mixed signal, we have 2 kilohertz, we have 50 kilohertz. We mix them. We got a third signal, right? Like this one, right? It looks like one signal, but it is actually not one signal. It contains two different frequencies. But here we cannot see them in the time domain. We can only see them in the frequency domain using spectrum analyzer. So this one spectrum analyzer is showing you the frequency domain of this signal. So in frequency domain, you are seeing two different frequencies. So here this signal is not just one. These are two signals together. Do you understand now why do we use spectrum analyzer?
Yes, clear.
For what? For what?
I understand because there is two frequency, but in the circuit here, only one.
No, not circuit.
No, I not mean circuit. I mean the frequency, Mr. Samir.
Look, if this is one signal, okay?
Yes.
And this is another signal, okay?
Yes. Together.
When you mix them, you don't get you don't get something like this.
Same
you don't get something like this. Its shape is changed. You will get something like this.
Yes.
It looks like just one signal, right?
Yes, but it's two signal.
But it's basically this one.
Yeah, this one I mean.
One.
Yeah, this one I mean. Yes.
So how do I know now if I give you a signal like, let's say I give you this signal. Can you tell me how many frequencies are there?
I asked two.
How do you know that?
Because
this is I can check how many frequencies are there by using a spectrum analyzer. I will send the signal to spectrum analyzer and it will show me something like this.
Yes.
So here I can find out how many frequencies are there in the signal. That's why we are using here spectrum analyzer. Now you got the idea?
Yes, clear.
Okay, just one last point and then I will take up your queries. Now this is time scope. Now look, if I click time scope here, I will first connect time scope with the carrier, another one with the, one with the information signal, another with the carrier, and third one with the output signal. Let's see how it looks like. And I will simulate it again. This is same like oscilloscope, you know. I hope all of you know how to use oscilloscope. What is this one? Sine wave, but with a low frequency. This is your information signal having 2 kilohertz frequency. What is this one? Carrier wave, having very high frequency. But when you mix them, what do you see here? Only one signal, right?
Yeah, only one signal.
But its amplitude is changing.
Yes.
Here, this is the double sideband signal, but here we cannot find out how many frequencies are there.
I use analyzer if I want.
Yes, that's why we added analyzer here to check how many frequencies are there.
Now clear.
Now I hope it's clear. And
yes, clear.
Hopefully it's clear. If this is clear, means you have done all the experiments, believe me.
Inshallah.
Now, what do we need to write in this? Oh, I'm sorry. I went to the wrong page. Anyways. So here, what do you need to write here? In this is your lab report, right?
Yes.
In lab report, you will have to fill up the amplitude of the carrier. What was that? How much was the amplitude?
Can I see the amplitude 10?
Can you tell me exactly, is it exactly 10?
No, not 10, maybe 9 or
So you don't know exactly,
yeah.
right?
Yeah.
But you can go to tools,
Yes.
measurements,
Yes.
and cursor measurements. Click on it. Now you will have cursors available. 1 minute will come up. Yeah, you see this one cursor now? Do you see this?
Yes.
So here you can find out the value.
7.9.
It's around 8.
Yes.
Or you can
Yes.
choose this
Yeah.
one. I think there's an option called
7.9.
settings.
8.
Right click. I don't exactly remember. Okay, you can check it out. Okay, just play with this tool and see. So it's almost 8. You can take 8. So the information signal has an amplitude of 8, right?
Yes.
And how do I know the frequency of the information signal? Again, go back to spectrum analyzer. This is your spectrum analyzer, right? Here, I connected this one to the output, but can I add one more option as input? Right click and then click signals and ports, add more inputs. I'll put 3 inputs, okay? How many inputs do I have now?
3.
3. So first one, I am using output. The second one, I will measure the information signal frequency. The third one, I will measure the carrier frequency. Is it okay now? So it will show me three signals. One is, what is the frequency of the output signal, which is this one? What is the frequency in the input signal? And what is the frequency of the carrier? Do you understand this?
Yes.
Let's see. Let's run it again. Now I connected 3 inputs. You will see there will be 3 peaks, 3 different signals. So what do you see here now? So what is the frequency? This is your input signal. Sorry, this is your information signal.
Yes.
What is the frequency of the information signal? Again, go back to tools,
40.
measurements, then click cursor measurements. What happened? Oh, there is something wrong with this analyzer. It doesn't work here. I have to simulate it again. It doesn't work. If it see, sometimes it doesn't work. So what you have to do is you just delete this one. Okay, go to library browser. You see this library browser here?
Yes, doctor.
Yeah, library browser, and then you write here spectrum analyzer. Search.
More steps, Mr. Samir.
No, it's you will, if you remember, all these steps is same for all.
I must
For
repeat
all the
previous,
experiments.
because now I not do it. Just I see what you do after I make it.
See, in all the experiments, what we'll do is we'll talk about amplitude modulation, we'll talk about frequency modulation. Sometimes we will change frequency, sometimes we'll change amplitude. But at the end of the day, what we're doing is modulation. That's it. So this is your spectrum analyzer. Just take one of them. Let's say we'll take DSP spectrum analyzer. Okay, here
Dr. Samir, when we will use the browser, the spectrum? If what? If not showing us that graph, or?
No, spectrum analyzer is used to measure the frequency. Look, I have connected an oscilloscope.
But it's already showing for me this one. Can I share my screen to see?
Yeah, sure. But wait a minute. I will take your signal. Just 1 minute. I'll just 1 minute.
No
Let me show you first this one, then we'll go back. See, I want to measure this signal here. I will connect oscilloscope to this one. Okay, this is the information signal, right? I'm measuring it here on the scope. Now, if I open up scope and if I run it, what do you see on the scope? What do you see on the scope? You see the signal, which is coming in from this DSP block, right? This is the signal that you see on the scope. This is a time domain signal. In time domain signal, you cannot measure the frequency. You cannot find the frequency directly, how many frequency components are there. That's why now I am connecting this one here. What is this? Spectrum analyzer. This one will show me how many frequencies are there in the signal. Watch. I will run it again. What do you see?
Small frequency.
It's showing you a frequency channel measurements. Wait, there's something wrong with the spectrum analyzer. Just a minute, I need to change this one. Spectrum DSB. Let's take SimScape. Averaging spectrum analyzer. It's a little bit slower. Okay, let's run it again. And let's simulate it again. Now here you should be able to see the frequency of 2 kilohertz. You see here highest peak. Watch. I'm going to expand it. What is the frequency now? Yes. What is the frequency here? What is the peak?
2.
So that means this is showing you that this frequency, the frequency here in the signal is 2 kilohertz. So we have a 2 kilohertz coming in, and that's true. Similarly, if you want to see the frequency in the carrier wave, now I connected with the carrier signal, right? Let's see what it shows for the carrier. How much is the carrier? Let me expand it. Where is the carrier?
15.
You see? You see what do we see on the scope spectrum analyzer? Now, if you want to see both the signals at the same time, right click. Okay, first I'll show you both all the signals on the scope. So this is your carrier signal, this is your information, and this is your output. So on the scope, this is your scope. How many signals should be there? Information signal, carrier signal, and the double sideband signal. Let's run it. We didn't connect the frequency spectrum. Just a minute. Do you see time scope? So time scope is like it's basically an oscilloscope that will show you three signals: information signal, the carrier wave signal, and the time domain signal. Sorry, and the output signal, because we connected three inputs, right? Information signal, carrier signal, and the output signal. That's why you are seeing three signals here. But you can only find the amplitude and you can only find the time. You cannot find the frequency here. How do I find the frequency? By using spectrum analyzer. So right click on it, and then how many ports are there? How many input it has?
One.
One. If you want to add more inputs, right click on it and then go to signals and ports. Number of ports, let's say 3, because we need 3 signals, right? We want to measure 3 signals, so that's why I'm choosing 3 ports as input. Now we have 3 inputs. First one, I will measure the input signal, which is information signal. Second one, I will measure carrier. Third one, the output. Is it okay? Do you understand now what we're doing here?
Yes.
Right. So let's run it again. So here you should be able to see 3 frequencies. So here you have got three signals in time domain. And what is this? What is this one?
The carrier?
3 frequencies.
Yes.
Hello. Hello.
And what is the yellow one, doctor?
Yellow one is the information signal, 2 kilohertz. And when you mix it with the carrier of 15 kilohertz, you get 2 sidebands. You can label them by using this view and then click on legend. Do you see this one?
Yes, information signal.
Carrier wave and product. Product means the multiplication. There's another way to simplify this. Just a minute. Tools, analyzer, CDF measurement. No, this is the problem with this analyzer. I don't like it. Now I have to restart again this program. Anyways. Okay, and now you got the idea what we're doing here, right?
Yes.
Perfect. Just 1 minute and then I'll stop. It's not connected. Now we will connect it. 1, 2, and the third is the input signal. Run it again. See, sometimes it's a problem with this spectrum analyzer. See, before it was showing you the results, now it's not showing anything, right? So, so what you have to do in this case, you close this file, okay? Open it again. So open this file again. This is a problem with the spectrum analyzer, so don't worry about it. It's a problem from the MATLAB, so not from us. Okay, I will run it. Spectrum analyzer. Let's take this one. Let's take this one and this one.
Mr. Samir,
Yes.
For me, actually I got confused.
Where?
Everything,
Where?
from the first one.
I mean, we didn't.
So
do
I need to see the video record, then I will do it. Because I messed up a lot.
Again, in the output, what we're measuring is the 2 kilohertz. We're measuring 15 kilohertz. We're measuring 2 sidebands because this oscilloscope, this frequency analyzer, spectrum analyzer, is measuring 3 signals at the same time, right? That's why you see 3 different signals. I hope now this is clear. I think we're done with this. So what you need to do is you have to measure these parameters now. Not these. This one here. Do you know what is the frequency of the amplitude of the information signal from this plot? How much is the amplitude?
I must to check.
We take it 8, right?
Yeah, this one was 8.
Okay.
And what is the frequency of the information signal?
How we get it?
You remember this one? Exactly, it's 2 kilohertz. You remember this one?
Yes.
How much is it?
Maybe 3?
No, it's 2. You need to measure tools and this one. But before you do that, remove this block from here and connect this spectrum analyzer directly to the information signal, because sometimes it stops working. Here I am just measuring. I am only measuring the information signal. What is this one? Information signal. So I am only measuring the frequency of the information signal. Because the spectrum analyzer has some fault. I don't know why it stops. Now you should be able to see the frequency of the information signal. Is it? Just expand it using this one, tools, then go to zoom x-axis. So expand it like this. So what's the frequency?
2.
Right. So you will write here 2 kilohertz. 8 is the amplitude, 2 kilohertz is the frequency. What is the carrier? Carrier is? What is the carrier? What is the carrier amplitude?
1.
1. What is the carrier frequency?
Carrier frequency.
15. Yes. You can again measure it from here. Connect the frequency spectrum now with the carrier here. Remove it and connect it here on this line to measure the carrier frequency. Okay. And then do we have double sideband suppressed carrier signal? Yes, we do. This is the double sideband suppressed carrier signal. What is the amplitude of that?
I go for the tools.
You have to take maximum amplitude. Yeah. Here. And what is the frequency? Can you measure frequency here?
I go to the tools.
How many frequencies will be there in the double sideband?
2.
2. Which one? Which one? 15 plus 2 and 15 minus 2, right?
Yes.
So you will have to write here upper sideband frequency and lower sideband frequency. Will there be any carrier frequency available?
No.
So there'll be nothing here. The modulation index is given by AI over AC. Do you have AI here? Do you have AC here? So can you find the modulation index? And can you take the pictures of this one? Time domain, which is this one. Can you take a picture of this and insert it here?
Which one? This one, huh?
Time domain, yes, it has to be here. And then this one, frequency domain, which is this one. So can you do it?
Yes.
Sure. Allah, we will try.
Abdurrahman, you have to do it.
Inshallah, inshallah.
Inshallah. So there are some. So with this one, I think I finished. I will leave rest to you how to do it. Just practice with it. Next week I will see. And for the first week's submission, I'm giving you more time for 1 week. So please practice MATLAB, practice it thoroughly so that we can be ready for the next experiment, and we should be able to to have our concepts ready for the next experiment. Everything will be repeated again. Just there will be a change in the modulator, because that's a different modulator than what we use today. But the result collection and result simulation procedure will be same. There's no difference. So if you're able to do this experiment at home, you can do the other experiments.
Yeah, I
Just
must do.
Just check out this one. How do we find out? I've shown you all the steps. Now you need to find out these parameters. Can you do it? And with this, I will stop here. Those who want to share screen, now they can share screen. First, I will take Abdullah Al-Dawela because I told him to stop in between. Abdullah, are you there? Abdullah, can you hear me?
Yes, doctor, I hear you.
Yes, please go ahead. Share your screen.
Okay.
Mr. Samir, can I leave, please?
Yes, we're done. Thank you.
Thank you, Mr.
Thank you,
Abdurrahman, no
Professor.
problem. Abdurrahman, Uzair.
See
Any
you.
one of you, if you have any questions, I'm here. So please go ahead one by one. Okay, you opened up MATLAB account. That's okay. All right. Abdullah, what you have to do is, did you download the file which I told you from that Moodle, KCST Moodle account? MATLAB.zip. Hello, can you hear me? Hello?
Yes, doctor, I'm with you.
Yeah. I had shown you one file which you need to download from
File to download it.
KCST.
I didn't download it yet.
No, please download it.
Okay.
Can you give me access to your PC?
Okay.
Okay, here. Go to this week and scroll up. Here, go to labs. And here you have this file. You see this MATLAB student.zip?
Yes.
Click on it and it will start downloading. Is it downloading? I cannot see it from here.
Yes, doctor, it's downloading right now. They put for me scanning for verses.
Right. Once it downloads, then you drag and drop
the file right now.
No, don't open. Drag and drop and the same file here in this one. Drag and drop that file here.
Okay.
Just do that and I'll come back to you.
Mr. Samir.
Anyone else? Yes, please.
I downloaded it.
Can't drop it.
Can you show me, Hassan? share your
Yes,
screen?
I open it from iPad, so
Hassan Al-Dashti,
See?
okay. I remember you.
yeah.
Yes, it's good to see you.
Can you see? Thank
Yes,
you.
what do you, okay, drag and drop.
This
Hold and drag and go to that,
I have to drag this one.
yeah, drag it. Yeah,
Okay.
this one.
Okay.
Drag and put it there. Yes, yes. No, not there. Oh, yeah, this one. Yes, done. Wait for a while. Now it's uploading this file.
Yeah. Okay. Okay.
Once it's uploaded, right click on it and then click extract.
Okay.
That's it.
Okay. Thank
No
you.
problem. No problem. You're welcome. Anyone else?
Please, Mister, can you help me
Yeah, sure. Please
to
share your
editing the
screen.
file in the Mindful?
Please
Just
share
a
your
minute.
screen.
Okay, okay.
Okay, what's the problem?
We'll download this one first.
No, not the new one. The first one. Down, third one. Yeah, this one. MATLAB student.zip, not the new one.
This one or this?
MATLAB student.zip.
Okay, this one.
Yeah, this one, yes.
Yeah. Then?
Then see if it's downloaded.
Yeah.
Okay, hold on 1 minute. Can I see your screen, please?
Okay.
No, this is for online MATLAB. Just 1 minute. Click here. Click here. Okay.
Yeah.
Go to MathWorks,
Yeah.
right here, mathworks.com. Math. Yeah, this one. Click here. Click enter. No, it's there. It's there. Just remove WO. Select United States.
Here.
Don't worry. You see you see on the right corner here. Here you see this
Here?
one?
Yeah.
Yeah, click here. Click. It will take you to your account page. Select United States. Okay. Okay.
Where is the email for university?
KST, yes. Sign in.
Okay.
Okay. Click on this this SA here. Click
My account.
my account. Now
Then
on the left side you have got second option MATLAB online. Second option on the left side. On the left. Here.
Okay.
Click on it. MATLAB online. And here you have your MATLAB ready. So you don't have to install it.
Okay.
You remember you downloaded that file MATLAB student.zip. Drag and drop that file here. Click on the current folder on the left side. Close it. Close this one. No, not there. Wait. This one. Here. Okay, now you see this current folder here. Drag and drop that file here in this one. Okay. Okay, perfect. Now it's uploaded. Now right click on this zipped file and then click extract. Yeah, click extract. That's it. Now it's ready. You see the don't extract again. Wait. No. Click no. You see this folder here now? Right click on it. And then click. No, wait. Why are you deleting these items? Right click. And then click add to path. And then click select folders and subfolders. Now your MATLAB is ready.
Doctor, I can't drag my
Yes.
file. I don't know why.
Okay, can you share your screen, please?
Okay.
Guys, any one of you who wants to leave, you're allowed to leave. We are done with this session. But those who need help, they can stay.
With you, Mr. Samir.
Okay, no problem. Yes, Abdullah, where's the problem?
Doctor, I want to drag it. Like, see, that is the file.
I cannot see it from here. You're actually sharing the on MATLAB screen only.
Wait. I will open it again.
Okay.
New share.
Disconnecting. Sorry, I'm disconnecting
Share.
you. First, I will disconnect you. Wait. Okay.
Can I share?
Just 1 minute, Nora. 1 minute.
You see it, Doctor, now?
Yeah, I can see it now.
Okay.
So, can you give me the control of your PC?
Okay. How can I do it?
I will tell you.
Okay.
1 minute. You will
approve.
Okay. Yes. Now look. If I drag it here. No. Okay. Perfect.
Okay.
No, you are sharing only one screen. Actually, you need to share screen, not the window.
Wait.
You are sharing the screen. You need to share screen, not the window.
Share screen.
Yes.
Okay. Okay, they put for me 4 items, Doctor.
Okay.
Okay, this is the screen. Wait. New share.
Yeah, no, I think now it's okay. Now it's working.
You see it?
No. I can see it, but I can only see the MATLAB screen.
Right, new share. Doctor, there is EE35. Okay, proof. Oh, it's gone.
Okay,
I want to do it, but it's gone.
Okay, wait 1 minute. Remote control request. Okay, can you do it now? Perfect.
Did you got it?
Yeah, now I have it. Now I have the screen.
Okay.
So here we go to downloads. It's a bit slower. I cannot. Okay, can you click on the download this folder?
Download?
Yeah, download folder.
Okay. Where it is? Download. You mean in the
window which is open right now in front of you, the white window. Here you have got this in the address bar. You can see this PC, then EE352 student_student, right?
Yeah, EE352 MATLAB student.
Right. Go to downloads.
Okay.
Actually, I cannot see anything from.
Yeah. Okay, sorry.
Okay, downloads. Yes.
I click and download. Then
click.
Okay, it's they put for me.
This.
PDF.
Yeah. No, wait.
Okay.
Hold on. This is the zipped file, the first one. You just drag and drop in the browser.
In the browser?
Yes.
Okay. Wait, so I will
Sorry,
right click.
No, not right click. Just drag and drop.
Okay.
I cannot see it from here.
It's uploading right now.
Uploading done. Then
Yeah,
it's
uploading file. Okay.
Okay, Abdullah, listen. Once it's uploaded, you
It's
right
uploaded.
click. Yeah, it's uploaded. Now right click on that and then click extract.
They put for me.
The first option is extract. Can you share your screen?
Yeah. Yes, sure. Share to the
No problem.
Did you receive it?
Not yet. Yeah, now I can see it. Yes. Okay, you have this folder now uploaded. Right click on it.
Okay.
No, I cannot see anything. Okay, go ahead. Right click.
Right click. Okay.
No. Go back.
Then?
No. Wait. Give me the control.
Okay.
Go back here. Click here. Okay. Scroll down.
Down?
Scroll down, yes.
Okay.
I cannot see it from here. Yeah, go ahead. Go. Move down. Scroll down.
Okay.
Okay, go ahead. Scroll down.
I go.
Where's the file? I cannot see that file. Where did you put that? Can you drag it again here?
Okay, doctor. Sure.
Drag it again.
Okay.
The same zip file that you found in the downloaded folder. Folder.
It's uploading right now.
Yeah, this one. Drag and drop.
It's
That's
uploading.
It. Okay. Wait.
Okay. Okay. So I will click OK, huh?
Yes. Okay.
Okay.
Click
Then.
OK. Just now you see the zipped folder there. Right click on that.
Yeah. Yes. Okay.
Right click.
So
No. You are using left click.
Extract. They put for me extract.
Now click on extract. Yes.
I had click on it.
Now you see the folder is added.
Then?
On the top. You can see there is a folder added now. We have one more folder added top.
Yes, sure.
Yeah, but it's dim. It's very light.
So
it's not. So what you have to do is you have to again right click on it. Again right click on it.
Okay. Okay.
It's a little slower. Wait. Slowly. Right.
So I had clicked and right.
No, you need to click it on the name. On the name. Right click on the name. Not there.
Okay. Here. Or here.
Yes. Right click, not left click.
Okay.
I'm sorry. One minute. Yeah. Right click and then go to down the third option from the down. Right from the bottom, you have the third option, add to path. You see? In this list, there is a third option, add to path. Hello, can you hear me? Hello? Hello? Hello, can you hear me?
Yes, doctor, we can.
Abdullah, I think lost connection. I think he lost connection. He's not hearing.
Mr.
Abdullah, can you hear me? Yes, Ahmed.
I want to share your screen, please.
Sure. Before this, there was Nora because she was waiting for a long time.
Yes, I want only check.
Nora, please go ahead.
Okay.
Ahmed, just 1 minute, please.
Okay, no problem. No, take your time.
Now
Yes.
it's working, right, doctor?
Yes, it's okay. Now click on AM.
AM.
Double click. Simulation, yes. And then click on AM. Yeah, down. You see these files, the files which have an extension SLX. You see this file has extension SLX. Yes. We are using these files. These are Simulink files, okay? So you will always need to click on these files, SLX. Double click on it. Wait, it's a little slow. Wait. Okay, here you have the window. Okay, can you simulate it? Can you run it? Can you maximize the window, please?
Wait. This one?
No, the main window of MATLAB. Okay. And just click run. Just click run. Let's see if it works. Okay, hold on. Initializing, and here you have the results.
It's working,
That's it.
doctor. Thank you so much.
No problem. Ahmed, yes, please go ahead.
Okay, Mr. Samir.
No problem.
You see, Mr. Samir?
It's starting up, I guess.
Yes, this offline.
Yes.
What
yes.
you prefer? I work with offline or
both are same. There is no difference. I mean,
I installed the zip
MATLAB.
file. Yes.
Okay.
But check if work is okay or no. I give you control.
See. The problem is what you have downloaded is student new. You see this?
I don't download.
I'll show you. I'll show you 1 minute. Can you give me control?
No problem.
Thank you. You can see here. It says MATLAB new. You see?
Yes.
We don't need new. We need the third one. You have downloaded the second file.
I cancel this now.
Yeah, just go to this folder, MATLAB.
Okay.
And here add that new file again, new folder.
I install now new and I check with you again.
Yes. Can you do it? Just keep it as it is and just do it. I'm watching.
Okay. 1 minute. Student, huh?
Yeah. In the meanwhile, if anyone has questions, please you can ask. If any one of you have any questions, please go ahead.
Document, right?
Right. No, not documents. You have to. You need to go to the KCST course page, and there you will find a folder. With the name lab exercises.
1 minute.
I'll show you. Show you 1 minute.
I open the 1 minute.
I'll show you 1 minute.
Screen.
1 minute. I'll show you. Do you see this KCSE page? Ahmed, can you see my screen?
Yes.
Okay, 1 minute. I will show you where it is. Okay, here go to the. Do you see this folder? digital community, then you have this folder here, lab exercises.
Yes.
Click on it.
Yes, I
And
installed.
this one we need
Yeah,
this one,
yeah,
not this one.
I install it. I
Okay,
show you.
okay, that's great.
Yeah, I show you now. But cancel please the share screen. I show you.
Okay, I'll just 1 minute. Cancelled.
Where I go, Mr. Samir? Now this my PC.
Okay, so you download it should be wait.
Yeah, yeah. I copy it. This one. See? This one, Mr. Samir, you see?
No. You don't have to extract it. Wait a minute. Sorry, 1 minute. Just a minute. Yes. Okay, you extracted. Yes to all.
Okay,
And
this one.
Copy this folder.
Copy this folder. Okay.
Okay, go to this PC, then go to documents.
MATLAB.
MATLAB, yes.
Okay.
Paste
I
it here.
remove this
Paste
one,
it
huh?
here.
I
Remove it. Yeah, press delete and remove it. Now paste it here.
I lost my internet connection.
Okay, Mr. Samir. Now
Yeah, I'm sorry.
Wait. No problem. I'll come back to you. Just 1 minute. Ahmed, double click on the folder. Okay. Look in the address bar. You have the path. This PC documents MATLAB. You see? Click at the end. Click on the end. No, click on the end. Yeah. Copy this path.
Okay.
Copy. Go back to MATLAB. Yes.
Okay.
And put it there. Paste here. Oh, we're already there. Okay, we're already there. Go back one step. Go back one step. One folder before. Yes. Click. Now you see this EE352 MATLAB folder on the left side. It's light. It's light. It's not added. So right click on it. No, don't go inside. Go back. Right click. And then click add to path. Down. Yeah, add to path, and then click selected folders and subfolders. This option, yes, click.
Okay.
Now it's added. Open up. Open AM.
Okay. FM?
No, AM.
AM. Okay.
Yes. Simulation. Open. And open the first experiment, today's experiment.
This
AM
one?
double. Yeah, first one. Yes. Double click. Wait a minute.
No.
So you are using the offline version. Both of them are same. I mean, there is no difference whether you use offline or online. Both will give you the same results.
Yes.
And offline is a little bit, I think, heavier because it will make your system very busy.
Much heavier. Yeah, too much heavier.
Yes, MATLAB is very heavy. So what I would suggest is you should switch to online version. And in the beginning, I recommended online version because you don't need to install anything. And in some I mean PCs.
But for saving problem .m like this problem for online.
No, for this one you don't. No, for this one you don't have to write any code.
Ah.
Maybe in last experiments you have to write code. Experiment 6 and 7.
The online same way I put like this student.
Exactly same. Yeah, and it's much easier than this one. In
Where
online,
would I go? I have online.
okay,
This one I online.
you have to open up the account, the online account.
My account, this one.
Okay.
But too much lag.
It's a little bit slow, yes.
I don't know why it is very slow.
No, because we are using the.
I think here a problem because see.
No, because we are using Zoom. It's making your computer slow. So just stop sharing screen. It'll come up.
Now open.
Okay. Now drag and drop that file here, in the left pane.
Where I go?
You remember you downloaded the file student.zip.
Okay.
Drag and drop in this left pane. Not this one. No, not this one. No, not this one. The zipped one.
Ah, the zip one.
If you try to download this one, it will give you an error.
This one.
Which one? Yeah, this one.
Okay, I copy it.
No, not copy. Drag it and paste it there.
Where I go?
Okay, copy it.
Okay.
Copy and paste.
Where I paste?
Here on the left side, left pane. Left. Down. Yeah, right click. Up. Yeah, right click and then paste. Do you have paste option there?
No, paste not light.
Yeah, that's why I told you have to drag.
How I drag? Like this?
Yes. That's it.
This easier, I think.
So we did it finally.
Okay, good. This one.
Yeah, now right click on it and then click extract. Right click and extract. Yes.
Okay.
You see, now right click again. No, the first one. First folder, yeah, right click. And then go to add to path down. And click select sub, yes, this one.
Okay.
Now it's ready, you can use it. Yeah, you can use it now.
Now I use it, no problem, huh?
Open. Yeah, it's ready.
Okay, and offline?
Offline is also.
No.
Offline is busy. It needs a very fast computer.
Yeah, خلاص, I will
for MATLAB, I mean, you need a minimum RAM of 16 giga.
Yeah, my RAM 4 giga.
If it's no 4 giga, you need to give more food to your computer.
Yes.
Mr. Samir.
Okay,
Yes.
okay, Mr. Samir, thank you.
You're welcome, no problem.
I click right click, okay, then I click add to path.
Okay.
Then selected folder and subfolders, yes?
Yes. Could you please share your screen?
Okay, Doctor, because there is the network.
Okay. Actually, it will be difficult like this because I
leave, huh?
Sure. Ahmed, you can leave.
Thank you. Bye.
No problem. Okay, you can share Abdullah with this with your mobile cam. That's okay.
Okay, Doctor. Okay.
Provided it's clear because I need to see what you're doing.
I opened the camera, Doctor. As you see here.
Okay, yes, I can see. Okay, now click on EE352 MATLAB.
Okay.
Second one, second four. Double click. Double click. No. Yeah, click on this. Double click.
Okay.
Okay, now you have AM. Click on AM.
Okay.
Click again. Simulation.
Okay.
Now here you need to find the file AMDSB, the first one. Click on it.
Sure.
Click and then wait.
Yeah, I'm waiting.
It will automatically pop up with Windows. Spectrum Analyzer and the time scope window.
So I should wait, huh, Doctor?
Yes.
Okay. Here it is.
Now it's coming up. Just hold on. Hold on for a while.
Okay.
And yes, it's getting ready. This is time scope. The previous one is frequency spectrum, and the third one is application. So can you press the run button now?
Yes, sure. But wait. But Doctor, the first thing I will make new script.
No, we are not using script here. We are not using scripts.
Where can I find the run button here?
The run button is in the menu. No, not there. The window that is in front of you.
Yes.
Yeah, this one.
Yeah, here it is. Okay.
Yeah, this one. Yeah, click on it.
I had clicked. So I will wait, huh?
Yeah.
Okay, there is a paragraph here or graph.
This one is the frequency spectrum analyzer. This one is time domain scope. You see, now you have got the results.
Wow, thanks a lot, Doctor. So
no problem. Just try it again and see how it works. Look at the different parameters. Look at the different controls. You need to explore.
Okay.
Yeah. And if you have any questions next week, just come back to me again. I will try to help you out.
That's it, huh, Doctor?
You're welcome. You're welcome. My pleasure.
Like just
yeah,
practice.
that's it.
Okay, thanks.
First practice, I mean, try to measure now. Try to measure the parameters as I've shown you in this video.
Okay, yeah. Thanks a lot. I appreciate it.
That's it. You're welcome. No problem. My pleasure. So, anyone else? Is there anyone else who needs help?
Doctor, I can leave now?
Yes, you may leave now. Provided you have no questions. Maha Munira, do you have any questions? Maha, Ruwai, and Munira, do you have any questions? No. Okay, all right, then let's meet next week. Till then, bye.